Hello, today in the lesson we will learn how to solve double inequalities. In the previous lesson we talked about what is called a double inequality in mathematics and how it is written, how we represent the solution of a compound inequality. But today we will learn how to solve these compound inequalities. They are solved quite easily. Let's write down the inequality. I would like to draw your attention to the fact that we will read the double inequality from the expression that is written in the middle, between the inequality signs. So, the following inequality, x minus 5, greater than or equal to 6, but less than or equal to 8. To solve this inequality, we need to find all the values of the variable, which we will substitute into the original inequality and as a result obtain a true numerical inequality. How can we solve such inequalities? We will simultaneously transfer the numerical value to the left side and to the right side, while keeping the variable between the inequality signs. What am I talking about? If I leave the variable x, I need to transfer the number minus 5 to the right side and simultaneously move to the left side. And then I'll be left with only the value of the variable x. I write x greater than or equal to 6 plus 5. When transferring a number or variable from one part to another, we use the same rules. I had minus 5. I move it to the left with a positive sign and move it to the right part. This is a very important technique. You simultaneously transfer this number to both the left side of x and the right side. And then we get 8 plus 5, and then I can perform the operation. And now let's perform the action. X is greater than or equal to 6 plus 5, which is 11, but less than or equal to 8 plus 5, which is 13. As a result, we find that when x takes a value greater than 11 but less than 13, our original inequality turns into a true numerical inequality. Let's check. I need to write down a value that is greater than the number 11 but less than the number 13. Let's take the number 12. Suppose that x equals the number 12. Let's return to our original inequality. And instead of x, let's write 12. 12 minus 5 should be a number greater than 6 but less than 8. 12 minus 5 is 7. And indeed 7 is greater or equal to 6, but less than or equal to 8. This is true, therefore we correctly solve this inequality. I can show the solution to this inequality, indicate on the coordinate line. On the coordinate line, I mark a point with a coordinate equal to 11 and the coordinate of the point 13. And as a result, I find that the interval between the numbers 11 and 13 is the solution to our inequality. Of course, this solution can be expressed as a numerical interval. X belongs to. If we say that the answer is written from left to right, then we say that the solution to our inequality will be all numbers from 11 to 13. And then I will write it down from 11 to 13. The brackets will be square since the inequality sign is non-strict. And now we will solve another inequality, in which I will switch x and minus 5. 5 minus x is greater than or equal to 6, but less than or equal to 8. Of course, double inequalities can contain one strict sign and one non-strict sign. But this will only affect the way the answer is written and the understanding that, for example, the number 11, if I write it down, x is greater than 11 but less than or equal to 13, then in this case I will understand that the number 11 itself will not be our answer, and the number 13 will be included in our answer and will be. But for now, we will work with those inequalities that are written on both the left and the right using the same signs. Now, let's move on to our inequality. 5 minus x is greater than or equal to 6, but less than or equal to 8. Note that I will move the 5 once again simultaneously to the left side and simultaneously to the number 8. And then I will have minus x, because x is written with a minus sign. Greater than or equal to 6 minus 5, but less than or equal to 8 minus 5. And then the value of minus x will be greater than or equal to 1, but less than or equal to 3. But this is not the answer yet. Why? The fact is that we have minus x in the answer, but we need x. And now a very important point when solving such inequalities. We must divide by the number, by the coefficient of x, and this coefficient is equal to minus 1. If we in an inequality divide by a negative number or multiply, then the signs change. That is, as a result, we get x is greater than or equal to minus 3, but less than or equal to minus 1. But we talked about the fact that in this form, double inequalities are not written in mathematics. Therefore, I will start reading x is greater than minus 3 and writing correct, but less than or equal to minus 1. And this answer will be the correct answer. When solving double inequalities, as you have noticed, we use the same rules. But when we multiply or divide by a negative number, in this case the signs change. But we talked with you that in this direction the signs in a double inequality are not usually written in mathematics. Therefore, after making the decision, you must change these signs, accordingly move the corresponding numbers and write them down in the correct order. Our answer x is greater than the number minus 3, but less than the number minus 1. And let's show this on the number line. The number minus 3 and the number minus 1. The number minus 3 is located to the left. And then the answer is all the values of x that are located between the number minus 3 and the number minus 1. In the next lesson, we will continue solving double inequalities. That's all for today. Goodbye. See you next time.